Today we're going to begin our unit on circles, and the lesson or the first lesson that we're looking at is just the basics of circles. So the vocab we need to talk about, the angles that are included with circles, and the different line segments. So I'm going to briefly go through the vocab, but this is definitely something that you should come back to and look at yourselves. I'll read through it, I'll talk about naming, and then I'll emphasize it throughout this lesson. But again, it's imperative that you understand all of this. It's something you should be learning on your own. So the first vocab word that we're talking about is simply just a circle. So in a circle, or in a plane, a circle is the set of all given points equidistant from a given point called the center. If we look at our diagram over here, this point is the center. And if you put a point anywhere on the circle around this whole thing, it's the same distance to that center. It's actually called the radius, which we'll get to that vocab word in a second. So when we name a circle, we're going to name this circle as circle P because the center is labeled as point P. Or you can abbreviate the word circle with what looks like a circle and a center point, and then just use the correct letter, which the letter is always that center point. So that brings us to the vocab word of center, and the center of a circle is the point inside the circle that is the same distance from every point on the circle. We already labeled that point, we already talked about what it is. Next up is the diameter, which is a segment that contains the center of the circle and has both endpoints on the circle. So if I draw a diameter goes straight through the circle. It has two endpoints, one here, and it intersects at the center. It absolutely has to go through the center. In my diagram, I already have a diameter labeled for you, and it's this one here. It's segment AB. So we will label that as a diameter. You should all know what a diameter is, just like you should know what a radius is. And a radius is the segment that has one endpoint in the center and the other endpoint on the circle. A new vocab word is called a central angle, and a central angle is an angle whose vertex is the center of the circle. So if we're talking about a central angle, we're talking about this angle here. That's an example of a central angle because the vertex, this point, is the center of the circle. Next, we're going to talk about congruent circles. So congruent circles are just like what they sound like. They are circles that have congruent radii, which means you have two circles that have the exact same radius. I'm just going to make a quick note. I'm going to indicate for my model that radius xy is congruent to radius mn. And because of that, I know that circle x is congruent to circle M. Next, we're looking at concentric circles, and these are circles that are coplanar and with the same center. So it appears like one circle is inside of the other circle. That's what concentric circles are. Think of a target or a bullseye. Those are concentric circles. They fall within one another. And the next set of vocab words is semicircle, minor arc, major arc. Three terms that are very important. We use these terms a lot. So a semicircle is a half circle. You name a semicircle by its endpoints and another point on the arc. So here is a semicircle. You absolutely have to use 3 points to name a semicircle. So I'm going to name this semicircle as point T, S, and then R. The endpoints have to be the end of the name. So when I'm naming the semicircle, I'm naming it as T, S, R. And again, the endpoints are at the end, the extra point is in the middle. You also put an arc over the top of this. It is not a straight line, it is an arc. Next, we're looking at a minor arc. A minor arc is smaller than a semicircle, and you name it only by its endpoints. So it's only 2 points when you name it. If a minor arc is smaller than a semicircle, then an example could be right there, points R to S. And that's how I will label this, RS with an arc above it. And lastly, we have a major arc, and a major arc is larger than a semicircle. You name it with 3 points. So we start at R, let's make our semicircle, let's go past that to point S. So this starts at endpoint R, we see point T, and then we continue to point S. I'm going to name this as RTS with an arc above it. So it's very important to make sure you get the naming correct. You will be graded on the naming. You absolutely have to make sure it is correct with the correct number of points, and you have to have that arc above it. So let's move on to the example where we're going to practice naming these major, minor, and semi-arcs. So question 1, what are the minor arcs of circle O? So circle O has a center point of O, and minor arcs are all arcs that are smaller than a semicircle. So I see this arc here, which is AD. I see this arc here, which is CE. I also notice that I have an arc here, which is AC. And I have another one here, which is DE. Next, we need to name the semicircles of circle O. So semicircles are exactly half a circle. Semicircles are determined by a diameter. So here's a diameter. That means we have a semicircle on each side. We have a semicircle here, and then of course we have a semicircle on the opposite side. So if I name the two of them, I have my endpoints. I'm going to start with this one I have highlighted in green. I have endpoint D, extra point A, endpoint C. The opposite side of this, I have endpoint D, extra point E, endpoint C. I also have another set of semicircles because here is another diameter. So I have this semicircle, endpoint A, C, E. And I have the semicircle opposite, A, D, E. Lastly, we're going to name the major arcs. So major arcs are larger than a semicircle. I'm just going to visualize this. I can see that I have a major arc here. It goes past the semicircle because it goes past the diameter. I'm going to use point D, A, and then E. I could have used D, C, and E. It doesn't matter. You just have to make sure you have your endpoints and one other point. So anyways, I'm going to say D, A, E. I see that I have this semicircle. So ACE is how I'm going to name that. I just said semicircle, sorry, major arc. ACD. I used endpoint A, extra point C, endpoint D. I'm going to keep working around my circle. I have this here as a major arc, endpoint A, DC. And I think the last major arc that I see is this one here, which is EAC. So again, when you're using 3 points, you're either naming a major arc or a semicircle. If you're using 2 points, you're naming a minor arc. On to some measures. So a minor arc is smaller than a semicircle, and the measure is equal to its central angle. So right here, RT is a minor arc, and that arc is equal to 50 degrees. A major arc is equal to 360 minus the remaining central angle. So here's our major arc. We would do 360 minus 50, which leaves us 310 for the measure of that major arc. All right, I subtracted 50 because it's the remaining central angle that is not included in the green highlighted section. And a semicircle, you probably all know, a semicircle measures exactly 180 degrees. So the arc addition postulate is exactly what it sounds like. It tells you that you can add arcs together. And adjacent arcs are the arcs that you add. So adjacent arcs are arcs of the same circle that have exactly 1 point in common. You can add the measure of these adjacent arcs just as you add the measure of adjacent angles. So what this is saying is, if you have arc AB with common point B and arc BC, again, we have a common point. This tells us that we can add up the total. So the measure of arc ABC is equal to the measure of arc AB plus the measure of arc BC. Make sure you're not using an angle sign, you use an arc symbol. Very important. We've been using angle symbols all year. Now we're using an arc symbol. Please do not mix them up. So example 2, we're looking to find the measure of each arc in the circle O. Circle O is this circle here because the center is point O. So I'm just going to remind you as we go through what the rules are is finding the measure of major, minor, and semicircles. Number 1 is BC, which is this arc here. BC is a minor arc, so minor arcs are equal to their central angle. So if this central angle is 32, then we know that arc BC is also 32. Next up, we're looking at BD, which is this entire segment here. This is when you add your arcs together. We can see that we have 32 degrees for BC and we have 58 degrees for CD. So we're going to be adding the measure of BC plus the measure of CD, and this is going to give you the measure of BD. So when we do this, we have 32 degrees plus 58 degrees, and this is equal to 90 degrees. 90 degrees is your final answer. Next, we're looking at arc A, B, C. So A through B to C. This is a semicircle. So semicircles are automatically equal to 180 degrees. The measure of arc ABC is equal to 180 degrees. And for the last arc, we're looking for arc AB, and that is this arc here. So you are going to have to get a little creative with this. We know that this whole arc is 180. We know that this smaller segment is 32. So in order to find the measure of arc AB, what I am going to do is I'm going to take my semicircle of ABC, and I'm going to subtract the measure of arc AB. That would be this arc here. I said that wrong, BC. And that's going to give me my total. So this is equal to 180 minus 32, and that gives me my solution of 148. So the measure of arc AB is equal to 148 degrees. For the next set of questions, we're looking at intersecting circles, and we're dealing with the diameter and the radius. So for problem 1, it says the diameter of circle A is 8 inches, the diameter of circle B is 18 inches, and the diameter of circle C is 11 inches. So besides from the diameters, I'm just going to make a note. So if the diameter of circle A is 8, that means the radius is 4 inches. If the diameter of circle B is 18, then that's telling us the radius is 9 inches. And circle C, the radius would be 5.5 inches, or I'll write 5.5 inches. So we need to use this information, add, subtract, whatever you need to do to the segment in order to find these pieces. So first we're looking at segment FG. So segment FG is this segment here. Okay, well, based on what I just wrote down, we know that this entire diameter is 18. We also know that this smaller segment right here is the radius of circle A. The radius of circle A is only 4 inches. So to find FG, what I am going to do is I am going to do AG minus AF, which AG, the total length, is 18, and AF is 4, giving me the length for FG at 14 inches. And next we are asked to find the length of FB. So FB, we're going to use a very similar process. We're looking for this segment right here. And we know that this total length, based on the given information, this total radius length is 9 inches. And once again, we know that this radius is 4 inches. So in order to find FB, what I'm going to look at is the radius AB minus the radius of AF, which is 9 minus 4, and then that tells us that segment FB is equal to 5 inches, and that would be our solution. Of course, we could ask you a lot more questions about this diagram. These are the only two we asked. But what I would like everyone to do is try the next question by yourself, press pause on the video, come back and check your answers against mine.